We're putting 6.1 and 6.2 together, and we'll be graphing and solving one-step inequalities. Each time we do that, we'll have to make a decision about the endpoints. We'll use an open endpoint, which means it's not filled in if we have a less than sign or a greater than sign. And that means that that exact point is not a solution. It's like the limit of the solutions. They run right up to it, but it doesn't include that point. A closed endpoint just means we're going to fill it in, and we'll use a closed endpoint if we have a less than or equal to or a greater than or equal to. And that means that that point is a solution. It is going to be one of the things that works. We'll also have to decide each time which way we're going to shade. We're going to shade to the left if the variable is smaller than the number. So if the symbol is pointing to the variable, we'll be shading to the left. We'll shade to the right if the variable is bigger than the number. So if we have the variable, or the symbol I mean, in eating the variable, we'll shade to the right. Okay, so let's try this. In this first one, x is greater than or equal to -2. I find the -2. I see that the symbol has the equal, so that means -2 is exactly one of the solutions. This is saying all the x's have to be greater than or equal to -2. It's okay to be -2, otherwise they have to be anything that's greater, and greater is shading to the right. Okay, this one says that -4 is less than or equal to x, so I'm going to go to the -4, and it's going to be filled in again because, again, it has that little equals with the symbol. It means -4 is one of the solutions. The mouth is eating the variable, so it means all the things that are bigger. Because another way to say this would also be to say x is greater than or equal to -4. That would mean the same thing. So we want all the stuff that's bigger than -4. Let's try these with write an inequality and graph. Okay, you have to be at least 18 years old to vote. I'm going to start with a graph. So I know that if you're exactly 18, that's okay. So I'm going to make a graph and fill it in because 18 works. Otherwise, you have to be older than 18. The inequality that would go along with that, I could say x is greater than or equal to 18. Someone else might write 18 is less than or equal to x. They're both fine. They both say exactly the same thing. The maximum capacity of the bus is 78. So I'll put my 78 on the graph. I'm going to circle it. The maximum capacity means you could have exactly 78 people. So I'll include the 78, or you would have to have fewer. So I'll shade to the left. And this time I'm going to say x has to be less than or equal to 78. Somebody else might say 78 is greater than or equal to x, and they're both fine, as long as the inequality symbol is pointing at the x. So when we solve the one-step inequality, just like we did with an equation, the goal is to get the variable by itself. I would subtract 9 from each side. -16 minus 9 is -25, and that symbol just drops straight down and stays exactly the way it is. Then to graph that, I will put the -25 on the graph, circle the endpoint. I'm going to color in this endpoint because the symbol has the equals bar, and it says x is greater, and greater is always to the right. When you do this in Schoology, you need to tap the endpoint. Well, first, on the bottom, you have to pick if you want the opened or closed endpoint. So you choose that button, then tap the point that you want, and then you have to tap the line and kind of drag it, and you have to drag it until the arrow appears. If you don't drag it far enough, it won't count it as right. Okay, so for this one, I want the w by itself. My step that I need to take is to add 5 to both sides. I'll get -7. The symbol just stays exactly the way it is. And then this time I would pick an open circle. And it does, the mouth is not eating the variable. It's really telling us w is smaller than -7. So I'd shade to the left. In this problem, to get g by itself, I'd subtract 7.5 from both sides. And that's -12 3/4. I'll keep the symbol. I'd find the -12 3/4 on the graph. I'd put a closed circle there. You have to choose your endpoint ahead of time, though, so think about that ahead of time. Pick the right one. And then g is greater. The mouth is eating g, so it goes to the right. Okay, when you do multiplication and division, and only with multiplication and division, you sometimes have to flip the inequality symbol over. And that's only if you multiply or divide by a negative number on both sides. I'm just going to show you quick with a 4 and 8 over here why that happens. So what happens is, say that I multiply first I'm just going to multiply both sides by 2. So when I do that, I would get 8 is less than 16, and the relationship hasn't changed. The side that was smaller is still smaller. But say that I multiply by a negative. I'm just going to multiply by a -1. So all I'm really doing is just changing their signs. But when I change their signs, I change which one's bigger. So the -4 now is bigger than the -8. And that happens anytime you multiply or divide both sides of the inequality by a negative. You're going to have to flip over the inequality symbol. It's true with dividing too. So just imagine that I divided by, let's say I divide by a -4. And so this would become a -1 and a -2, and the -1 is bigger. Okay, so in this problem, to get the p by itself, I would divide both sides by a -5. And when I do that, I would have to flip over the inequality symbol. And then on my graph, I'd have a -11, closed circle, because I have a bar, and p is less than or equal to goes to the left. So we're saying -11 could be an answer, and so could anything smaller. In this problem, I'm dividing both sides by 3, and I will not flip over the symbol, because even though I'm not dividing both sides by a negative. So the relationship about which one's bigger won't change. I'm going to have a closed circle and shade to the left. And then in this last one, I would divide both sides by a -7, and I get a +4, and I will have to flip over the sign because I'm dividing both sides by a negative. Open circle, and the mouth is eating the variable, so shade to the right. W is bigger than 4, and it cannot be exactly 4. Okay, same rule and just 3 problems with division now. So in this problem, I'm going to multiply both sides by -9. Because I multiplied both sides by a negative, I have to flip over the symbol. In this one, I would multiply both sides by a -6. And I get a +72, and I would have to flip over the sign. Oh, I guess we're supposed to graph these. Okay, so 72, open circle, W is greater, shade to the right. Okay, then on this one, I'm going to multiply both sides by 3. I will not flip over the sign, because I see there's a negative there, but I'm not multiplying both sides by a negative. So the symbol stays as less than sign, which means that K is greater, and I'll shade to the right. Don't color in the circle, leave it open because there is no equals bar. Write the inequality, solve it, and graph it. Maybe just now we don't need to graph quite so many. So let's just write the inequality and solve it. Product of 6 and h, product is multiply, so I have 6 times h, is at least. Like if I told you you need to bring at least $20 on this field trip, you would need to bring greater than or equal to. Is at least is greater than or equal to. So 6h is greater than or equal to -84. Divide both sides by 6. I won't flip the sign, but I'll get a -14. The product of m and -5. So we have -5 times m is not more than. So if something is not more than, like if I said, this bicycle is not more than $35, it could be less than or equal to 35. So then we'll divide both sides by -5. And this time I will flip the sign because I divided both sides by a negative. And then quotient, division, W divided by -2 is at most, means that it has to be less than or equal to -82. The most it can be is -82. I'll times both sides by a -2. I will have to flip the sign, and I'll get a positive 164. And finally, the quotient of D and 4 is less than negative 25. When I multiply both sides by 4, I don't flip the sign because I'm not multiplying both sides by a negative. So we'll leave the symbol just like it is.